Today we're going to be talking about arcs and chords and their relationships in circles. So that theorem 10.2, what that says is that in the same circle or congruent circles, if two minor arcs are congruent, if and only if their corresponding chords are congruent. That means that if we have the chords congruent, then these arcs are going to be congruent. And then the converse of that is also true. If I have my arcs congruent, then the chords are going to be congruent. So our first example here is a circular piece of jade is hung from a chain by two wires around a stone. I have JM, chord JM congruent to KL, arc KL is 90, so I need to find the measure of arc JM, and that is also 90. So the measure of arc JM is equal to 90 since I have congruent chords in our circle. Next example, in our figure, circle A is congruent to circle B, and I have that WX is congruent to YZ. I need to find the length of chord WX. Well, if I have congruent arcs, then I have congruent chords. So I have 7x minus 2 is equal to 5x plus 6. I'm going to subtract the 5x over. I'm going to add the 2 over. And I'm going to add the 2 over correctly. And so I get x to equal 4. I need to find the length of WX. WX is equal to 7 times 4 minus 2. And that is equal to 26. Next, when we have a diameter perpendicular to a chord. So if a diameter of a circle is perpendicular to a chord, then it bisects the chord and the arc. Meaning that I have diameter AB perpendicular to chord XY. That means that YZ and XZ are congruent, and then the arcs BY is congruent to XB. And then we have another piece of this theorem. A perpendicular bisector of a chord is the diameter of the circle. So if I have a segment that goes through the midpoint, it's the perpendicular bisector, then we know AB is going to be a diameter. Okay, in circle G, the measure of arc DEF is equal to 150. So let me write that in there. That's 150 for this whole arc. Find the measure of just arc DE. Well, I have a radius, which is part of a diameter, perpendicular to a chord. That means that HF is equal to DH, and also that chord DE is congruent to arc DE is congruent to arc EF. So if the whole thing is 150, I cut that in half to get 75. In the circle below, diameter QS is 14 inches long and chord RT is 10 inches long. Find UV. So I have a diameter that's perpendicular to a chord. That tells me that U is the midpoint. So UR is equal to UT. So this is equal to 5 and this is equal to 5. They tell me the diameter, the whole length of here is 14 inches. That means my radius is 7 inches. and I'm trying to find UV, this segment here. Well, I have a right triangle. So the hypotenuse squared is equal to one leg squared plus the other leg squared. So I have 49 is equal to 25 plus VU squared. VU squared is equal to 24. So if I subtract the 25 over, and then we square root both sides, square root of 24 is equal to VU, but remember we want everything in simplest radical form, so I have 4 times 6 is equal to VU, so I have 2 root 6 is equal to VU. The next example. In the same circle or congruent circles, if two chords are congruent, if and only if they are equidistant from the circle, from the center of the circle. So if FG is congruent to JH, if and only if they're the same distance from the center of the circle. Okay, so in circle P, in our example here, EF is equal to 24. GH is also equal to 24. I need to find PQ. Well, if I have congruent chords, then they're going to be equidistant. I have to have a right angle there. Equidistant from the center of the circle. So 4x minus 3 is equal to 2x plus 3. Be careful solving this equation. I could see where you might make a mistake with this. Subtract the 2 to get a 2x. Now add the 3 over to get a 6. X equals 3 in this. Remember, I'm trying to find PQ. PQ. Okay, there's PQ. Is 4 times 3. This is what PQ is. Minus 3. That's equal to 12 minus 3, which is 9. That's my video on arcs and chords. Thanks for watching.